Welcome back. I'm Mrs. White, and this is video number 3. Today we're going to start measures of variation, also known as measures of spread or dispersion. So here we go. In this video, we are hoping that you will learn about how the measures of central tendency tells us more about the shape of a distribution. You will also learn how to calculate the range. You'll learn how to calculate the variance and the standard deviation both by hand and using the TI-89. And I will also teach you the symbolic notation for the standard deviation and the variance. Okay, so the first thing we're going to talk about is what happens when the mean, the median, mode are all the same. So that's what we have right here, all three, all exactly the same. You'll notice when this happens you have a symmetric shape. Now symmetric means that it's the same on the left as it is on the right. So in this case it could be a regular bell shape, but it could also be something that's bimodal like that. So you see mean, median, mode all the same in the same place. That's what symmetric means. So that's one indication that the mean, median, mode would happen. Now imagine for a minute that you added another point right over here, right? So you had one over here. What would happen to the mean? The mean would move up over here. This is where the mean would be. The median would stay about the same, and so would the mode. So the median might move a little bit this way. Okay? So you have mean, median, mode, like this way. So notice, remember, they have mode, median, mean, like this. So when you have mode, median, mean, you move on to something that we know is right skewed. Okay. Again. So here we have an example of right skewed. When the mean goes, when you add something to the tail over here, pulls the mean up. Same exact thing happens if you add one down over here. It's going to pull the mean over here. It's going to pull the mean to the left. The median might move it down a little bit, and then the mode will stay the same. Right? So if it's left skewed, the mean will be to the left of the mode. Mean to the left of the mode. So negatively or left skewed has the mean left of the mode. So the order of the mean, median, mode can tell you a little bit about the shape of a distribution. So they're all the same. You get symmetric. If you have mean to the right, you get right. Mean to the left, you get left skewed. Okay, so today we're going to look at two small samples of comparison from Outdoor Paint, brand A and brand B. And you'll notice they both have the same average code. So the averages are here. So, and then right here, notice that they both turn out to be the same, both brand A and brand B. So what else can I find out about this is, let's look at the mean and the median, or the modes and the median. So let's take a look at median for brand A and for brand B. The median for brand A will be right here at 35. The median for brand B right here for 35. All right, let's take a look at the modes. No mode here. This one has a mode of 35. So now we have the mean, the median, and the mode all at 35. Okay, mean, median, mode all at 35. So this doesn't tell us a whole lot about the differences of these two brands. It really is not very helpful. So now we're going to look at how much do these two brands vary, because they seem to have the same central points, but how much do they stretch out? How much do they spread? So the first thing we're going to take a look at is the range. The range is a pretty old-fashioned statistic. You guys have been doing it for a long time. So the formula for the range is real simple. It's a traditional range formula, and it is the highest value of the set minus the lowest value. So the range is equal to max minus min. Right. So that is one measure of variance. The range is one measure to tell us how far a set will vary or how much it spreads apart. So for our paint example, let's take a look at the range for both sets. So let's quickly calculate the range for both brands. Brand A is going to be our highest, which is 60, minus our lowest, which is 10. So I have a range of 50. Brand B, our highest is 45, our lowest is 25. That's 20. So now we're starting to see a little bit of this here. Brand A has a longer spread than brand B. So brand B, we would say, is more consistent. Another measure of variance is called standard deviation, and it's a really important measure. A lot of statistics is based on the idea of standard deviation. So we're going to work with a really simple set. It's called 2, 4, 6, 8. Okay, so if we look at what this set looks like on a dot plot, we have, there's 2, there's 4, there's 6, there's 8. 2, 4, 6, 8. So if I consider something on this set, let's look at the mean. And this is a population that we're looking at. So I'm going to look at the population mean. The population mean is 20 divided by 4, which is 5. The population mean. So if we take a look where that mean falls on our picture, the mean's right here. So the idea about variance and standard deviation is basically standard deviation is the average distance away from the mean. Now, one way you could obviously calculate the average distance away from the mean is to just take each distance. So you'll notice that this distance is 1, negative 1, going backwards. And then this distance is negative 2, going backwards. And then you have a positive 1 and a positive 2. So one way I could think of this is, hey, I'm just going to take negative 1 plus 1, negative 2 plus 2, and add them together and then divide by 4. The problem with that is that you end up getting 0 every time. No matter what 4 numbers you start with, the distance would always average out to 0. And that's basically because of the way the averages work. So you have to find a way of making these numbers all positive. Now you could use the absolute value. If you remember, the absolute value is just taking a number and making it positive. The problem with that is absolute values as a graph have very pointy edges. They're very pointy. And when you use very pointy things, they don't have derivatives. And derivatives end up being really important in the future when you're talking about minimizing error. So we don't like to use absolute values for this application because then we have this very pointy problem, the pointy problem. So we don't. So instead, we square things, because when you square something, you also end up with getting a positive number, and that's what we're really looking for. So if I square this, if I take 1 times 1, I get another little square that has an area of 1. And if I square this one, if I take something that's 2 times 2, I get this area right here that has an area of 4. 2 times 2 is 4. So I have an area of 1 and an area of 4. And then on the other side, if I square this little one, 1 times 1, I have an area of 1. And then if I square 2, the 2, I also have an area of 4. This is called the squared deviation, right here. This is called the squared deviance, because this is how far it deviates from the mean, and it's squared. So I have a 1 plus a 4 plus a 1 plus a 4. So the sum of this square deviance is 10. And now I'm going to divide that all by the total number in my set, which is 4. And that equals 2.5. So 2.5 is the average square deviance. We also call that the variance. And the variance is the average distance away from the mean squared, 2.5. So then the standard deviation is just going to be the square root of that. So the standard deviation, you standardize it, get it back in the same units. The standard deviation is going to the square root of 2.5. So we square these all, and then we take the square root to get it back in the unit. So the standard deviation, which we call the average distance away from the mean, is the square root of 2.5, which is approximately 1.58. So this is about 1.58 on average away from the mean. Okay, so this is the green slide, and the green slide is going to be where we actually write down the formulas. So we just learned how to do the variance, and the variance is symbolized by this. That's a sigma, it's a Greek letter. It's for population, so we always use Greek letters for populations. And the squared is for variance. So the squared is for variance. So sigma squared. And the formula looks like this. The formula is sigma squared is equal to the sum of each of those differences from the mean squared variances, the sum of the deviations, divided by the whole population. So what you have here, remember that we're using this mu because it's the population, and a capital N because it's a population. Now the standard deviation formula will just be standard deviation, and we just use sigma, not the squared, because you take the square root, you get a sigma. And then this would just be the square root of the formula that we have above. There we go. There you have it. So that's formulas for the variance and the standard deviation. Okay, so now we're going to take a look at how we would find the population standard deviation on the calculator. And we're going to use this set right here. We're going to pretend like this is the whole population. So the first thing we're going to do is we are going to go to our stats list editor. So take the data and make sure you enter it into list 1. If you're going to follow along with me, each one of these into list 1, just like you did for the mean. And then you're going to choose F4, one variable statistics. When you hit enter, you will see a screen like this pop up, and you will see that right here is our standard deviation, our population standard deviation. This right here, our sigma x, is our population standard deviation. If you want to find the population variance, you have to take that number and square it. So you just go to your home screen on your calculator and you take 213.26 and raise it to the second power, and you end up with this variance. So that is your variance. So population standard deviation over variance. There you go. How to do it on your calculator. Now I'm going to show you how to find the standard deviation if it's a sample. So we're going to use the same exact set here, but this time we don't know it's a population. In fact, we know it's a sample. So same exact set, same idea. We are looking for, we have 2, 4, 6, and 8. We know that our mean falls right at 5. This time it is a sample mean, so I will write it like this. The sample mean is 5. Right? And now we're going to take the difference from each point, subtract it by 5. So we have 2 minus 5, and then we're going to square that. Plus 4 minus 5, going to square that. Then 6 minus 5, square that. 8 minus 5, square that. So we have 3 squared plus negative 1 squared plus negative 1 squared, excuse me, positive 1 squared, plus 3 squared, right? So again, we're going to have 9 plus 1 plus 1 plus 9. That is 20. So we have 20 divided by 4. Now, it's not 4 this time. Because we have a sample, you don't use n to divide by. You use n minus 1. So you use 3. So our new variance is going to be 20 divided by 3, which is 6.6667. All right, that's our variance, and then our sample standard deviation, and I blew that. This is sample variance, so we don't use sigma. We use sample for s squared. Therefore, our standard deviation, we use s. Sometimes books will call it sx for standard deviation, is going to be the square root of 6.66. And if we do that, 6.67 square rooted is approximately 2.58. Right? So this is the sample standard deviation. Now remember that it's not the same as what our population was. It's different. It's a little bit bigger. Because when we have a sample, we like to overestimate it. It becomes less biased if we overestimate it by a factor of n minus 1. So that is how you do it by hand. Right? We're going to go now to the green scene and write the formula down. Sample variance. Remember, this is how we write sample variance, s squared. And then the formula is the sum x minus the sample mean, because we have a sample, squared, divided by n minus 1. Now for sample standard deviation, you just take the square root of that big formula. It's the whole sum, every point minus the mean, square it all over n minus 1. This n minus 1 makes it an unbiased estimator. Again, we're overestimating because we have a sample. So we want to make sure that you have that there. Okay? All right, so these are our important formulas. Now, nobody in the free world calculates standard deviation by hand. I'm going to ask you to do it once on a quiz and then not again. So you need to be able to do it with a small little set of 3 or 4, but that's it. I won't ask you to do it for a larger set than that. You will always be using your calculator. So let's go over again how you would do this on your calculator. So for your calculator, what we're going to do is use that same problem that we did with about police incidences. And again, this time it's a sample. So again, you need to add it all in to your list 1. Hit F4, one variable statistics. It's really important that you have list 1, and frequency 1. Remember that frequency has to be 1. Frequency is 1. Up pops the screen. Same screen as before, but this time we're looking for sample standard deviation, and you will see that it is right here, sample standard deviation. It is the SX, right? In order to find variance, you need to take that SX on your home screen and square it. So your standard deviation is 226.196, and then your variance, that thing squared, is 226.196, and raise that to the second power. And you're going to get 51164, so 51,164.63. All right, so really super easy to do it on the calculator. Again, nobody's going to do it by hand. I'm going to ask you to do it once because it's really important that you understand for the future of this class what exactly standard deviation is. Standard deviation is the process of measuring points from a distance, squaring it, and adding that deviation up. So we are going to do this several times throughout the course of this class. Use this idea of taking squares and adding them up and looking at this squared deviation. Squared deviation. We add them up and we look at the average of that squared deviation, and that's essentially what standard deviation is. It tells us on average how far is things away from the mean. Average distance away from the mean. Away from the mean. All right, great. All right, so I made up a little song some time ago that goes like this to help you remember that the square root of square root of variance is the standard deviation, and it goes like this. Variance, variance, it measures volatility. It's based on the mean, and the root is the standard deviation. The root is the standard deviation. Variance, variance, it measures volatility. It's based on the mean, and the root is the standard deviation. The root is the standard deviation. It's a catchy song. I encourage you all to sing it in the shower or wherever you love to sing every day. So I am hoping that you learned a lot in this video. Again, we know that if you look at where the mean and the median are, we can tell a little bit about the shape of the deviation if they're right together. It means the deviation is symmetric. If the mean is to the right of the median, right skewed, left of the median, left skewed. So those are important concepts. The next thing I'm hoping that we learn from this video is how to find the variance and the standard deviation, both for populations, which are written like that, and for samples, which are written like this. And I'm also hoping you learned a new song you can sing in the shower that goes like this. Variance, variance, it measures volatility. It's based on the mean, and the root is the standard deviation. The root is the standard deviation. Awesome. Have a great, great weekend. Yay, stats. Go some.